Welcome to the Ames Water Plant. My name is Lyle Hammis. I'm the Water Plant Superintendent. We are one division of the Water and Pollution Control Department, which is made up of 5 divisions. Of course, this is the Water Plant Division here on East 13th Street. Here we also house the Administrative Division, which is made up of the Director, Assistant Director, Engineering, Environmental Specialist, and Secretary. We also have the Water Pollution Control Plant, which is the wastewater plant. That is located southeast of Ames. We also have the Lab Services Division, which does laboratory work for both the water and wastewater utility. And we have the Water Meter Division, which maintains all the meters throughout the distribution system. Ames is a little unique, somewhat, in that usually from the treatment plant through everybody's houses, everything having to do with water production and distribution is in one department. We're actually not. Some of the responsibilities for getting water to people's houses and the businesses falls in the Public Works Department. The easiest way to think about that is everything you can physically see having to do with water or wastewater treatment above ground is our department. That includes the treatment plant, the towers, some of the wells, the pump stations, things like that. Everything you can't see below grade generally is Public Works. That is the breakdown of how our department works, and there's a lot of interaction with Public Works. So this has been an exciting time here at the Ames Water Plant. We've been under construction and now operation of a new water treatment facility. This project actually began back on the 4th of July weekend in 2007. We knew a new plant construction or renovation or something was coming, and some real high water demands brought this to our attention, and we knew we needed to move forward with this sooner than later. So we hired a team of consultants, and for the next couple years we did pre-design, but first we really evaluated what could the old plant do moving forward for the citizens of Ames as far as producing water. And the team of consultants that we hired, we really, as we were studying this, we kind of learned that the biggest driver to doing something wasn't as much meeting the water demand, it was more the condition of the infrastructure at the old plant. So that really became the driver of the project. And we also in that evaluated 4 different options, whether it's a renovation of the existing plant or a new lime softening plant, a new membrane plant, a peaking plant, different options that we evaluated. In the end, the most economical way to move forward was a new lime softening treatment plant on a new site. So in 2009, City Council supported that, and we were off and running. So first thing we did is we had to acquire land to do this. So one place became real evident that we were interested in getting. It was actually owned by the USDA through the National Animal Disease Center here locally in Ames. There were some issues getting that piece of property, but in 2011, I believe we actually acquired it. So we knew where this new treatment plant was going to happen. So that was great. We began final design soon thereafter. And finally, in September of 2014, we bid the project in 2 contracts. One was the treatment plant itself, one was the piping between the new and the old. So, and fortunately, it came within budget. A month later, we had a groundbreaking ceremony, which was really exciting. Of course, city council members, people from the Department of Natural Resources, even somebody from the USDA was there to help everybody celebrate and break ground on this new facility. So that construction and ground was officially, they broke ground on the contractor a month later in November 2014. So for the next few years, almost 3 years, was the plant construction. And it was really, really neat. It gave me a new appreciation of the people that take projects from the engineering plans all the way through construction. Like I said, I really appreciate the skill and labor that those people put into it, and that was neat to see, and we were all involved. In fact, that's one of the neat aspects of this. People were involved all through this project, not only the supervisors and engineers, people that typically are, but also the frontline staff, the operators, the maintenance workers. They have a lot to add to these projects, and we have a lot better facility because we did include them. So this brings us to early 2017 when we were starting up the plant, testing all the different processes, the tanks, the pumps, everything that you can think of. And finally, on July 27th, 2017 at 12:10 p.m., that's burned in my memory forever and ever, we actually started releasing water from the new plant into the distribution system. So that was an exciting time for everybody. A month later, we had an open house, and we were working out the bugs for quite a while, particularly in the control system, but from day one, we were able to produce great water for the city of Ames. The water quality has not changed one bit, but our ability to produce water for the citizens of Ames moving forward has changed significantly. So if we've done it right, this plant will be around for almost 100 years, just like the previous one. So we've talked about a little bit about the department and about the plant construction and design, and now we're going to move into some of the details about the actual water treatment plant process. So follow me and we'll go ahead and go to our bench display and talk about that. We give so many tours here that in the design of this plant, we actually said, you know what, let's set this up and do this right. So we actually put together a display bench so we can talk through chemistry. Like I always tell people, water treatment is all about chemistry, and we give tours to all kinds of different groups, and it kind of definitely, depending on who you're talking to, you describe it a little bit differently. So this helps us facilitate that. We get our water from groundwater. We have 22 different wells. They're spread throughout 4 main well fields. We've got a downtown well field, we've got a few other well fields, and there's actually a 5th well field in construction right now. So we've got 22 different wells, soon to be 25, and they're all roughly 100 feet deep. We tap into what's called an alluvial aquifer. This model kind of shows a little bit about what you drill down into. When you drill a well, you actually do test drilling to find out exactly what it looks like. And what you're looking for is this area with the larger rocks, because you can kind of see there's a screen there. If you drill down into the larger rocks, water goes into the screen easier, and it's less apt to plug up over time. At any given time, about 1/3 of them are on coming into the treatment plant, and the first step you see is aeration. Aeration is a very simple process. Water goes up a pipe, splashes over baffles, mixes with oxygen in the air, and it moves on into the process. Oxygen has 2 main functions. First is to oxidize iron. We have very high iron in our water. And the second is to vent undesirable gases such as carbon dioxide, which lowers the pH of the water. Later on, you want to elevate the pH of the water in the chemical process. So the more carbon dioxide you can get out at this point, the better. It also vents off hydrogen sulfide, which smells like rotten eggs. You don't want that in your water, so you need to get that out also. So that's aeration. It's a very simple step. These 3 cylinders were taken from the exact same spot. The only difference is when they were taken. This is what we call raw water, or straight from the wells. We've done nothing with it yet. When we first took this sample, it was clear as could be, just like it comes out of your tap. As time progresses and it gets exposed to oxygen, it starts to oxidize, and iron actually changes forms and it becomes visible. So it gives it this color. This is the heart of the lime softening treatment process. We have relatively hard water here in Ames. Water coming in is about 400 milligrams per liter. It leaves at about 170 milligrams per liter, so we remove more than half of the hardness. Sometimes I get the question, how many grains per gallon is the Ames water? The answer is about 10. About 10 grains per gallon is the equivalent of 170 milligrams per liter. So what we do is we use a number of different chemicals, and the first chemical I'll talk about is lime. This is pebbled lime, is calcium oxide. We get about 100,000 pounds of this each week, and what we do is we form lime slurry. This is simply the calcium oxide mixed with water, which creates an exothermic reaction. It gets up to about 185 degrees Fahrenheit just on the chemical reaction. So we measure very precise amounts of the water and the lime, mix it together to form the slurry, which looks like milk. So we're going to simulate the softening process here. You can see the water has a color to it, but you don't really see any particles in it. So what's happening is there are 2 main constituents of water hardness. That's calcium and magnesium. What we're doing here is we're going to precipitate out or remove the calcium and magnesium hardness from the water. So now what you're going to see happen is the clarification, and you can already see that the lime, now we call this lime sludge. It went from lime slurry to now lime sludge. is starting to go down. And that's one of the two main things that happen in these solid contact units. Now, so what do we do with this lime sludge, all this sludge that we're forming? And we have what we call our lime ponds. We have 4 different lime ponds between the new and the old plant. One of them is the size of a football field, so they're very large. We'll discharge into one for a period of months, and then we'll go to the next one. Meanwhile, that first one dries out, and we'll have a contractor scoop it out and apply it to farm fields as a soil conditioner. So it works out really well. What's a waste to us is a benefit to the farmers to condition the soil. All the chemistry going on has to be monitored very specific times, or very specific places, very specific times of day and frequencies and so forth. So our operator, water plant operator, keeps really busy doing lab tests. And we test for alkalinity, hardness, iron, phosphate, fluoride, all kinds of different things. And again, you know, when we're explaining this to people, what our operators do, sometimes it's easiest to show. So particularly for little kids, we'll show them this. We added what's called phenolphthalein here, and this is to water, and phenolphthalein is an indicator of alkalinity. And so when you do that, kids aren't expecting. So this, again, this is an example of chemistry in action. It has to do with pH and alkalinity. So I tell the kids that our operators just make pretty colors, and that's an example of that. So back to the treatment process, we're done with lime softening, and now we move to disinfection. This is the most critical part of the treatment process. We used to add chlorine gas, and now because of safety reasons, we add liquid chlorine, which is sodium hypochlorite, which is just a concentrated form of bleach. So associated with that, we have to add a small amount of ammonia, so the two they work in combination with each other. But this is the most important thing we do. We could not soften the water. Wouldn't be smart because you'd plug up the pipes. We could not add fluoride, but there's proven dental benefits that make this a wise thing to do too. But the one thing we absolutely have to do is disinfect the water. Another chemical we add is called Polymer. It's this kind of sticky, gooey substance that it actually works with an ionic charge. A lot of these particles, you see a lot of this has settled out, clearly, but not all of it has. Because some of these particles have a natural repulsion to each other, and it's really hard to get them to settle out. Polymer helps this process. It helps the particles come together bigger and bigger so they can settle out easier. We also add, later in the process, fluoride. Fluoride is for dental protection, primarily in young children. Get a question about this a lot. The proven dental benefits of fluoride far outweighs any other considerations. It's relatively inexpensive to add, and so we've always added for quite some time fluoride. We continue to this day and plan to moving forward. So what we need to do is stabilize the water, and you do that 2 different ways. First, you actually add carbon dioxide back in, which seems a little silly because earlier I said you want to get rid of carbon dioxide, which was true at the time. Now you actually want to bring it back in because you want to lower the pH of the water. Again, it sounds silly, but the reason is this is the most economical way to adjust the pH of the water. So carbonation, recarbonation we call it, is the next step. Also, we add what's called phosphate. At this point, whatever hardness hasn't been removed, we don't want to remove it. We want the water to become more stable. Phosphate helps that process. Now, water stability is important in what we do. Water can be 2 main things. It can be very aggressive. It can eat things away, such as this coupling, and it can be very depositing, such as this pipe that used to be a 4-inch pipe. Now it's a 1-inch pipe because of the water chemistry, essentially. Our job is to make sure it's neither of those extremes, and it needs to be generally in the middle on the slightly depositing side. The reason is because everybody's heard of the Flint, Michigan issue. That had everything to do with water stability. To avoid what happens in Flint, we want to form a very thin shell of calcium carbonate or calcium deposits on the inside of pipes. The reason is, if there are any lead service lines out in the distribution system, lead can't dissolve and leach into the water and be swallowed and harm humans. So that's what happened in Flint, Michigan. They created aggressive water. It ate away at the inside of these lead pipes, and it has severe and permanent health effects. It's really sad because not only the current generation that's affected by lead poisoning, it's actually the next 2 generations also. So really bad deal. People tell me, could Flint, Michigan happen here? And I said, well, if we don't do our job, yes. However, even saying that, Ames is in a much, much better situation because out of roughly 20,000 service lines, we only have maybe 250 to 300 that are actually lead that we know of. And over time, these are getting taken away as we have water main replacements and things. These lead service lines are being removed. So Ames is inherently in a good situation, but we maintain the water chemistry very specifically to that, and we test for lead and copper as we're mandated to do. In fact, even do a little bit more sometimes, just to make sure. So a lot of these solids have settled out. You can see that in that cylinder here. As you can also see, there's really small particles that have not settled out yet. We need to get them out of the water. And we do this with a dual media filter. We've got 12 inches of anthracite or coal, it's the same thing, above 18 inches of sand above gravel. So water flows down through the anthracite. The larger particles get caught up in the anthracite. The really small particles get caught up in the sand. And these will run for 250 to 300 hours. And then we'll have to clean them. And the way we do that is we simply reverse the direction of water. Instead of water going down, it's now going up. It makes the media churn up. It gets all the particles out. It backwashes at a really high rate, like 5,400 gallons per minute, which that's a lot of water. So we don't want to waste that. So we actually return that to the head of the plant by the aerators, and we reuse that water. It just goes through the process again. So we're trying to be as efficient as we can with water. So filtration, again, is the last main step in the process. We do, like I said, 200 tests every day here. We do tests out in the distribution system. So there are a lot of different ways that we can check to make sure the chemistry is what it needs to be here at the Ames Water Treatment Plant.